Yes, hello. I would like to tell you a little bit about what I have learned about our universe. In my book, The Supertellic, Electromagnetic-Gravitational Universe and Technology Theory, I have illustrated a universe in which faster-than-light space travel is possible. The universe as we know it is set up in a certain way. It has a certain structure. At rest, and what I mean is at rest since the Big Bang and to a point where the universe has slowed to the speed of light, everything in it is formally at rest. But in my book, I suggest that there are 2 points in which there have to be research to discover how fast than light speed space travel is possible. One is our planet at rest orbits and rotates at a certain speed. This speed is what we decipher are days, months, years, and seconds. But there is a second place in the universe that is rest, that is not actually connected to the Earth. It's interstellar space, outside the Earth. That orbit, or rotation, is on a bigger scale. The scales of our planet Earth rotate on a 24-hour basis and 365-day cycle. That's 1 year. The universe, much larger. The Earth rotates inside a smaller realm than the universe as a whole. And the solar system, as well as the galaxy, rotate within this larger scale. This larger scale is cold matter, dark matter space, interstellar space. And this is where the difference in this orbit or arbitration allows for faster than light speed space travel. To explain this to you, I can say that for one thing, it's weightless. As such, without any outside interruptions, a ship traveling through interstellar space at any speed, uninterrupted by some event, massive event, or bumps, as you might say, continues to travel. But that doesn't say anything about faster light speed. Faster light speed is joined within the two barriers of space. One is the Earth's atmosphere, which contains gravity. What does gravity do? It slows down everything that's moving. It brings it to a stop eventually. And there's nothing that travels within the Earth's atmosphere or gravity that doesn't stop because of it. Those scientists are trying to find these elements that might allow this. They have not yet. But in stellar space, the whole medium and atmosphere, there's a great difference. And that difference is interstellar space is absent of energy. At least energy that affects the object. It's low density space, which means it's actually absent of energy. Or absent of everything. It's called empty space. A ship traveling in an empty space without interruption and relevant to Einstein's equations, would travel faster. And the way I can show this is that a ship traveling 1,000 miles an hour on Earth, and the ship just above the Earth's surface, it's slowed down. If you take the gas pedal off, what happens? It slows down. What happens when you go to interstellar space? You take off the gas pedal, you keep going. Big difference. Gravity slows down the object. How much does gravity slow an object down? Well, in my book, I decipher this event of velocity to meet 372,000 miles a second. That's twice the speed of light. The reason I've done this is because of time. There is an interrupting factor when you travel faster than the speed of light. Time. Because of this, I have created a second barrier. One barrier is the speed of light, and where time intervenes, and anything faster than that, time begins to travel backwards. So what I've told you is actually how it works. Gravity slows the object down in space. Any object traveling in space, even at the speed of light. Traveling at the speed of light, the object is slowed down to what? The speed of light. That's the next. Interstellar space. No interruption. No gravity. What's this allow? What's this allow? This allows for an increase in velocity. Speed. The ship. Speed, the amount of energy taken in to accelerate the ship, weighed against the amount of pressure from gravity, equals to 372,000 miles a second. Interstellar space travel backwards, forwards in time. A complete circle from Einstein's. Can we go faster than that? Well, traveling faster than that makes it a lot harder. When you travel forward in time into the future, traveling at the speed of light, and no faster, traveling to the infinite future. Get to the infinite future, travel accelerates past the speed of light. You begin to go backwards, back in time to when? To when you left. Okay. Now, again, you launch, second journey, you travel backwards in time, beyond the speed of light. How do you get backwards? Traveling backwards in time. You have to slow down and actually travel in the future. And the future measures parallel with the time that you travel into the past. You become travels to a point of launch from where you left, or even before that, a little bit before that, a little bit after. This is high theoretical physics. Mankind, it will take years, decades before this type of technology is actually going to be put in, for example, ships. I mean, we're talking about 20,000, at least 50. But I'll leave it open to whether a person can travel faster than what I call the quantum light speed. 372,000 miles